All right, so this is a Colab notebook. It's free. You just sign up for it. You just have to have a Google account, and you can run code on it. And you can also use a GPU if you want to for training an AI an AI program. We won't be doing that. We're not training an AI program. We're just uploading some vectors to a vector database. So what you do first is you download the text that you want right here, and then you install Pinecone client. Pinecone is that vector database. Oh, see, here we are. So you can change the runtime type. You can choose any kind of GPU you want. You can change it to hybrid. So here is Pinecone. This is the vector database thing that we talked about. And see here, words and ideas expressed in 3D space, like that. So this is pretty easy. You start it, you log in, and then you get like some passwords and keys. So now what you do is you create an index. Let's say text index. Oh, text index. Index just means database. Dimensions, we're going to use 1536 because we are pulling from, we talked about ADA 002, and that one has 1,536 dimensions, and the metric they use is cosine. So you can just read that on OpenAI's webpage, and you do starter, which is free, and free tier index, and then you just create an index. So we do create index right there. See, pretty easy. Now we've got our index. So that's our environment. And let's see, connect. Oh, it says initializing, so it's not entirely done yet. But when it is done, I can take host, and there's also like an API key, I think, that we need. So after I download some text and I install Pinecone client, which is the Python version of what you need to connect to Pinecone, you install OpenAI, and you make an account with OpenAI as well. And you get your API key. That's what this cell is. And then this is how you set up your connection to your Pinecone database. You have to have your API key, environment, and index name. So let's go back here. It says initializing. So there's my environment. I'm going to copy that. Environment, paste. API key. See where I'm not even sure if it has one yet. It's still initializing. So these are some statistics that describe our database. We have 1536 dimensions, like 3 dimensions versus 1536 dimensions. Index fullness, we have nothing in there. Namespaces, I'm not even sure what that means. Total vector count, we don't have any vectors in there. This is kind of an example of the format that you might want to use. You can use like a string and then the vector, right? So you just do index.upsert, a list of tuples, a string, and then a list of numbers. This is I just keep this here to remind myself of how to do it. Okay, so then we want to install LangChain, OpenAI, tick token, and Pinecone client for gRPC. All right. So then it looks like I already installed. Okay, so I downloaded this text earlier. So then I'm going to open my text file and read it into a variable. Then I'm going to print out some of it. All right. And the earth was out form, darkness void upon it. Great. So this is the part where we actually embed our text, right? So we do OpenAI embeddings, model name equals model name, and it was ADA 002. OpenAI key equals OpenAI key. And that's one that I put in earlier. This will actually embed things for us, but this will first split it. This is going to split things. Like we said before, we have to put things into chunks. We can't just put the entire Bible into one embedding because it kind of doesn't convey enough information. Remember, we only have 1,536 dimensions. And if we've got millions of words, then that's not going to be enough information. That vector is not going to be enough information to represent all those words. But if we have like 100 words, then yeah, that vector would probably do a pretty good job. So we're going to say maybe 400 characters, chunk overlap. So chunk overlap is like, if you want the words before the sentence and the words after the sentence to give it context. And you can do that. You can do that or not. It's kind of up to you. You do some trial and error and figure out what gives you the best results. So then we would do text splitter .create documents, and then it would, convert them into chunks. And then we would do embed documents. So for each chunk, we would embed it. We would take a chunk of like, maybe 400 characters, which is a couple sentences. We would turn that into a vector and it would put it somewhere in vector space. Then we would take the next chunk, which is like, 400 characters, and then we would put it into vector space. Put another one into vector space, another one, just over and over until we have this entire document, the entire Bible in vector space. So for example, we're also creating IDs just because, it helps to have an ID for each vector. So then we have, let's say we upload the first verse of the Bible. We would upload it. We would first convert it into an embedding. See this vector? This is what a vector looks like. First dimension, second dimension, third dimension, fourth dimension. All right, so then we create these vectors. We have an ID. Then we have our vectors, and somewhere, way down there, 1,536 items down the road, we have the text. So we have the ID, the vector, and we have the text. And we created those using our code, embed documents. Then we create a dictionary, Python dictionary, where we have ID and values and text, and we can have some metadata if we want to. And then we do index.upsert vector dict. And so we upsert those into our Pinecone database. Upsert just means, we send it to the database. Then after that, we're not done yet because we want to do a query. And like I said earlier, if we want to do a query, what we do is we take a string like this. We take, give me a verse about loneliness. And then we embed that query. We take this query and we turn it into a vector as well. So then what we do is we send this to Pinecone and we say, hey, Pinecone, this is a vector. I want you to give me the 3 closest vectors to this one. We can choose how many we want. We can be like 30, we can do 3. The higher number you choose, the longer it takes. But, 3 will probably be enough. Like 3 to 5 is usually enough for retrieval augmented generation. So let's say we tell Pinecone, give me your 3 closest vectors to this vector that I just sent you, which is the query vector. So it will pull back 3 vectors with their text. And it'll say, okay, I think these 3 are the closest. And it'll be like, 3 Bible verses about loneliness. And then you send those off to ChatGPT. You say, here's the user's question. Here are 3 pieces of data. I want you to use these to answer that question. You are a chatbot. Please use the following information to answer the user's question. And then the vectors. If you cannot answer the question using the given information, just reply, I don't know. Only answer using the provided sources. It's important to say that because you are setting it up for what you want it to do. Retrieval augmented generation also combats a problem with LLMs called hallucination. Sometimes you will ask a question of ChatGPT and it will just flat out make something up. And that's just one of the problems with AI, is that it sometimes makes things up. And so if you have a prompt like this saying, if you cannot answer using the given information, just reply, I don't know, only answer using the provided sources, that helps combat hallucination because you are giving it some short information and you are saying, here's the question, please answer this question based only on this information. Whereas if you ask it, like an open-ended question without answers, it's probably gonna hallucinate. It's gonna make stuff up. All right, so yeah, so that's basically the vector and query process and how to store them as well. You can also use things to upload many pieces of text to Pinecone. You don't have to just upload the vector and the text. You can upload a lot of other information too. Like you can upload the date. You can upload the question and the answer. You can upload the person who wrote it. A lot of different interesting data that you can attached to one vector. But you want to make the vector an embedded version of the thing that you want to search by. So if we want to search by the context, we want to search by the text, then we would embed that. And if we want to search by the author name, then we would embed the author name. Right? That is all that I have prepared for today.
Great, great. So, Tyler, people have enjoyed your session a lot. I can already see it from the comments, which are not stopping at all.
All right, thank you, Shreya.